So, we've successfully figured out everything we could about the people we're studying from the historical records. We figured out where archaeological sites connected with the people we're studying are located. We got permission from the landowner to dig, did all of the non-invasive testing that we could, then figured out where to dig through testing. We finished subsurface testing, completed our block excavations, and filled them back in after collecting the artifacts and mapping the features and soils at the site. Mission accomplished, right? Wrong. Once we finish the dig, we still have a lot of work to do if we want to understand what was happening at the site. In this stage of archaeology, we're taking the artifacts and information we got from the field and using some very special tools and techniques that can tell us a lot more about what was going on at the site. First, laboratory cleaning, drying, analyzing, and bagging. When artifacts are brought to the laboratory, they're cleaned of remaining dirt gently and then laid out to dry. When they're completely dried, the artifacts are sorted into categories: types of ceramics, types of stone artifacts, types of metal, types of glass, and so forth, counted and weighed. This lets archaeologists studying the site figure out where the different concentrations or groupings of artifacts are located and how many of each kind are in different areas. Second, some types of artifacts won't survive unless they're conserved. Conserving artifacts means treating them so they will survive longer. One of the most common kinds of conservation, called electrolysis, is done with iron artifacts. When iron artifacts first come from the ground, they may be so badly rusted that it's hard to tell much about them, or even in some cases exactly what they are. Electrolysis takes rusted iron artifacts and puts them in a chemical solution of water and sodium hydroxide. The artifacts then have an electrical current pass through them and the solution, as well as a sacrificial anode, usually made of fine steel wire. As the current passes through the artifacts in the solution, the chemical process of rusting is stopped, and the atoms of the rusted iron replaced partly with atoms from the sacrificial anode. When the process of electrolysis is completed, the iron artifacts are scrubbed and dried. Then, when they're very dry, the artifacts are saturated in a bath of wax or sealant to keep them from ever rusting again. Here we have examples of unconserved iron artifacts, and here below them, iron artifacts after electrolysis and conservation is done. As you can see, doing electrolysis can make a huge difference in preserving and interpreting iron artifacts. In doing electrolysis and conservation, it's important to always do it safely. So at the beginning, here are some important rules to follow. Always make sure to wear protective clothing, including gloves, a mask or goggles, and a covering apron. Never touch the rack or reach into the solution while the chargers are working. Always make sure they're unplugged. Make sure the area you're using for electrolysis is well ventilated, including a ventilation fan or a completely open space. And when doing conservation with hot wax, make sure you place the artifacts in the wax and remove them with tools. Never touch hot wax with your bare hands. Another helpful tool for archaeologists is the microscope, especially when trying to understand what an artifact is, if it's small, or what it's made from. Through using a microscope in combination with a camera and a computer imaging screen, an artifact under the microscope can be projected onto the screen to make seeing it much easier and to help find out what things were used to make it. If an archaeologist wants to know what elements are part of an artifact, a new technology has become available called X-ray fluorescence, or PXRF for short. A PXRF scanner uses a strong burst of X-rays to break down an artifact's composition and project the different elements it's made from into a computer. This means that archaeologists can look inside an artifact's composition and tell differences, for example, between lead or iron or pottery from Spain in the early colonial period or the United States from later in Americans' history. Finally, after all of the data have been gathered and the archaeologist has information to share about what they've done, The most important tool for them is the computer and the internet. When archaeologists have completed a dig, they have an ethical obligation to publish their work so that other archaeologists and the general public can learn more about the things they've found. Through publishing articles, blogs, and social media postings, as well as creating online archives and databases, archaeologists can share what they've learned with the rest of the world.